Alright, in this video we are going to go over the dplyr package, which is a foundational package if you are interested in learning more about data wrangling. And specifically, if you come over here and you type in like tidy data cheat sheet or dplyr data cheat sheet, you'll find this link. And what it has here is just lots of examples and the most common functions that are used by dplyr and tidyr. And I made another video about tidyr, so go check that one out if you are interested in learning that. This video is about the dplyr package. And as you can see, there are tons of things you can do with this package, whether it comes from filtering, sampling your data, slicing your data, selecting specific types of the data in there, conditional subsetting the data. There's just a lot that you can do with it. So we're going to do just an introduction into it. I'm not going to go through all of these functions. That would take a long time, but I feel confident that by the end of this that you'll feel comfortable learning how to use the rest of these functions with the dplyr package. So let's go ahead and jump in. So right up top, I'm just going to say library, dplyr, going to make sure that I have access to those functions. And I am going to read in a data set called bike buyers. And that is saved on my local machine, but I will make it available in the description of the video. So go look for that. So read CSV. We're going to view it just to get familiar with what we're working with. And it's basically a data set of different bike buyers and eventually whether or not they bought the bike. There's no information about the company or what's going on here, but it has some interesting data that we can look at. So let's learn about this data and let's wrangle this data with dplyr. So one useful function is the sample function. And so this function will select random rows by defining the number of rows that you want right here. So I'm going to save my sample in S1. And I'm going to use the function. It's called sample underscore n. And let's look at the documentation real quick. Let's bring this over. Sample n rows from the table. So we're going to pass it the data, or the table of data, and get 5 rows back. Let's make this bigger as well. So here we are. We got 5 rows back. And yep, 5 rows back with all the information here. And every time you run it, as you can see here, you're going to get different results because it's completely randomized. It doesn't take the top 5, the bottom 5. Those are different functions, head and tail. Sample n will just take 5 random samples. So a different way to interpret this, not to interpret it, but a different related function is sample frac, which stands for sample fractions. And you're gonna send in the data set once again, and you're gonna define the percentage that you want back from the data set. So right here, again, table size is 1, and so it's gonna be in a decimal format. So this one right here in the documentation is basically saying like 100%. You want all of it. We're just gonna say 0.2, so we want 20%. Brings back this, and it may look kind of crazy because there's not enough room to display it down here. If you want to see the data formatted better, use the view function, and this is 20% of the data. And if you look over here this is the row number, and you can tell that it's just completely randomized. It's got things from all over the place, as opposed to this, the bike buyers data set itself, 1, 2, 3, 4, 5, it's going to go through the whole data set. There's 1,000 entries. So in here, we have 200 entries. So this is really useful, especially if you get into predictive algorithms or you just want to subset your data and you want to verify and validate that the model that you have in mind works on a certain set of data before you use the full set of data. So let's look at the select function. A prereq for a lot of these is that it must be in data frame format because it uses those columns like these, let me show you, like marital status or gender, it uses these columns and it expects them to be vectorized. So really each one of these columns is a vector and it's just tied together in a data frame, meaning it's all one object in R. So let's look at the select function. This is a really common and popular and powerful and wonderful function within dplyr package. So select keeps only the variables you mention. Pretty simple. So it wants the data first, so we're going to select, send it the bike buyer's data set so it knows what it's looking at, and I want to handle only marital status and income. Those are the only variables with all the data that I want back. Uh-oh, object income not found. This is just a test because I want us to remember that R is case sensitive. So if we look at the data, income is spelled with a capital I. So we should run that and we'll get basically all the data from marital status and income. We'll get all 1,000 records or observations, but only these two variables. And so this is, again, this is a data frame if you were to look at it with two vectorized columns or variables. So let's say we want to drop a data set. I mean, you look over here at this ID column, and is this ID column going to do us much good when we're analyzing it? No, because it's just randomized numbers meant to keep track of transactions. And for the sake of this data set, we know that there's only one ID for each observation. Sometimes it might be different if you know that if a certain customer has a specific ID, then that would be a value that you'd want to keep. But in this case, this is just, I mean, this 1,000 entries is really only a sample from a bigger data set, as you can tell with the ID of 12,000. And whoever made this probably did a sample like we did up here. They probably got a sample and just pulled it out and they got 1,000 rows. So what I'm trying to say is that ID, that's something we don't want. And again, it's case sensitive. So we're going to save a new data set on top of, we're going to replace this bike buyer's data set and basically just save over, here it is, save over that data set by selecting bike buyers, and we're going to remove the ID column. So now let's view this. It's a little easier to view. We don't have the ID column, and that's one less thing that we have to worry about as we continue with our analysis. So now let's look at head and tail. This is pretty common. This isn't in the dplyr package, but it's similar to select. You just want the head. We got the top 3 records by showing this. You want the tail. You get the bottom 3 records by saying 3. So those are pretty common, somewhat related to this select function that I'm talking about. So now let's go back to the select function. There are variables, or the columns. It's most packages will refer to them as variables. I recognize them as columns, but they use them interchangeably. So based on a partial description, you're not really sure, either you're not really sure what the column is called, or you know you want all of the columns that start with a certain letter. So in this case, all of them that start with C. So let's use select, bike buyers, and starts with function. Select that, and let's see what we got. So we have children, cars, and commute distance. And those are the 3 columns. Commute distance, cars, they pass over, yeah, passed over children. There it is. So those are the 3 columns that start with C. And again, you can do the same thing. You can drop a column if you want to drop everything that starts with Y. So in this case, we don't have any columns that start with Y. I didn't want to drop anything, but it's useful to know that you can do that little minus sign and starts with whatever it is that you're looking for. So now let's rearrange this data, because let's say, you know, I'm interested in this data and I want purchase bike to be the first column over here, and I want to push everything else over to the right. So in order to do that, we're gonna save over the current bike buyers data set, because we're kind of arranging it in the way that we want. This is kind of what I'm doing right now is kind of just an opinion based, but it's helpful to know that you can rearrange the data. So you're going to do select bike buyers, then you're going to tell it purchased bike, and you want everything else. So basically you're selecting purchased bike and you're putting that first. That's why it's listed right here. It has this ... this documentation. Well, it's pretty much asking you what order you want the columns in. And then in this case, everything open and close parentheses says just get everything else and put it afterwards. So if we run that and use head to look at the first 6, by the way, the default is 6 if you don't specify. So now we have purchase bike right over there at the first column. So bike buyers, now we have this right up front. We can see it really, really easily. So now the rename function. Again, it must be a data frame, and you first supply the name that you want a variable or a column to be called. So let's say one of these columns isn't very descriptive, and maybe it has a weird ID number, or it's just a bad way to refer to data. This one is based on preference again. Purchase.bike isn't really something that I need as far as that naming convention. So I'm going to change it. I'm going to say bike buyers, rename bike buyers. So I'm telling the rename function what data to look at. I'm saying purchased, which is the new name that I want it to be known as, equals, so you're using the assignment operator, purchased.bike. So if you run that, use head, now it is just purchased and it's no longer purchased.bike. And we could do the same thing with marital.status here if we wanted to, and we could just name it married or m-status, whatever it might be. And that would work just fine. So now the filter function is also a really powerful one, because you can search based on single criteria, multiple criteria, whatever it might be, and you'll be able to pull back specific subsets of the data with the variables that you're interested in. So it looks like the filter, return rows matching, yeah, we want this one, return rows with matching, because it's in the package dplyr. Let's click on that. Return rows with matching conditions. So again, filter and then data. So it wants to know what data to look at here. And then you're going to give it the conditions. So we're going to filter the bike buyer's data set by marital status and use a double equal sign, because a single equal sign means that we are assigning some type of value to the variable or whatever we have listed here. A double equals is comparison. So we want all the marital status observations, the rows, that have the value of married. So here's the column right here. So we have all of the married observations here. Now if we want to get a little more specific, we can do multiple criteria here. I don't know why I said this. Multiple, how about that? And we're going to say we want all of the married and this ampersand symbol purchased. And you remember we changed the name purchase.bike to just purchased. We're going to use that double equals again. We're going to say yes, because that is the value in this column. So now we got all the married, purchased bike customers. So this will be helpful if you want to subset the data and you want to say, okay, what do these people have in common? You could take out this married section, and you'd get the married and single, and you could evaluate it and say, okay, what makes them special? Why did they buy it? What kind of trends do you see there? So let's look at multiple criteria. and this is for a single column multiple criteria. So this was two different columns multiple criteria, but this is a single column. So we're going to say filter bike buyers, so that's the data set. We're going to filter on occupation, so right here, this column. We're going to use this funny function. It's called piping. So it basically this little syntax here is us saying we're going to send this into the next line of code, and so we're going to look for skilled manual and just manual, because maybe we don't know the difference of that, and the difference is so subtle that it's not worth having them in different columns. So we're going to subset the data and just say filter on those two. So here we are. If we look at this column right here, we have manual and skilled manual under occupation, and that is accurate. That is what we want. So I just want to point out real quick that I'm not saving any of these results in any variables. I'd have to call it something like that, variable or occupation, whatever it might be. I'd have to save it in a variable, and I'm just kind of running these filters, and they're just being run but not stored anywhere. So let's look at another example of multiple criteria. Bike buyers, occupation once again, and then inside of occupation, we're going to look at skilled and manual, and then we're going to combine what we did up here with this ampersand, and we're going to say, and they need to have purchased a bike, and they're going to have to be single. So filter on that and see what happens. So we got skilled and manual, all of them are single over here, and all of them are purchased right here. So this is a subset of the data that we might find interesting, especially if you have knowledge about what the data set is. You can easily subset and filter through different things. Now let's look at, what if you don't want a column and you don't want to have to say filter and list all these columns that you want, but the opposite of that. You use this exclamation point. So you're going to say filter, send it the data set, and you're going to say not education equaling high school. So I want everybody except the high school education people. Perfect. So if we look through here, we're not going to see anything. And so we can change this even, and we can say, okay, and not education equals, let's get rid of the graduate degree as well. Let's see if this works. Okay, so drop the graduate degree as well. So you can easily put multiple nots in there, and it'll drop those specific rows or those observations. So that's the filter function. Very, very useful. Now let's look at the arrange function. And this is mainly for sorting the data. So use descending to sort a variable in descending order. Let's go ahead and look at see what that looks like. So we're going to use arrange, send it the data set like it asks here in the documentation. We're going to say descending, and we're going to pass it a column name. So here we are, the most amount of children down to descending to the least amount of children. It starts to change right here, but after that it kind of truncates it because it doesn't want to show everything. So descending, and again, you can now you can arrange things or sort things based on multiple criteria. So you want all the purchased descending, and then once you've ordered it like that, among those sorted categories, you want to make it descending in the order of children. So out of the ones that said yes and bought a bike, here are the number of children, it descends, and then eventually, let's try and find it real quick. So in order to view this, I don't want to save it, I just want to view it. I'm just going to put that into the view function. So here we are, yes, children. So let's scroll down until we see no. Okay, so no, we're at the bottom of the data set and they don't have any children. So it looks like it's doing the right thing. And now we're up to 1. So that looks correct. So now the mutate function. Let's go ahead and look at that. It's feature engineering. Feature engineering is a powerful, very, very powerful way to get your data set to be more accurate, especially if you're doing predictive analytics. A lot of people might try and update some type of like algorithm that they're using, some mathematical formula, whatever it might be, when in reality, feature engineering has proven to be one of the best investments of time when you want to get some of your models more accurate, your predictive models. So feature engineering is all about adding a new variable calculated from fields that you already have. It just so happens in this data set that there maybe isn't that many things that we can feature engineer. But if we wanted to, we could create an age to income ratio. I don't know what you would do with that, but we could find it. See right here, age to income ratio. We added a completely new column by dividing these two columns. You could even make it just age times income multiplied by. Now we get a even bigger number. Again, this is kind of a meaningless number in this data set, but again, feature engineering can be super powerful. So other things that this package can do, it can use joins, it can use intersect or unions, and I highly recommend that you come to this page and you kind of just explore, see what it can do, making new variables, summarizing data, grouping the data, whatever it might be that you're interested in when it comes to wrangling the data and kind of pulling out certain sets of the data. This package is pretty promising if you want to do that. A related function that I don't think it's in the dplyr. No, this is just in the this is just in R itself. You can subset and you can send it multiple criteria. I haven't changed this for the right data set, but yeah, it's very similar. And if you look here, subset, bike buyers, you can select certain columns and then you can set criteria. So the power in this comes from the fact that you could possibly select certain columns and then set the criteria for one of the columns that you didn't even pull in. And that can be pretty powerful as well. So hopefully this gets you off to a good start in understanding what the dplyr function does and basically what you can do with it and how it can be an aid to your data wrangling. So thanks for watching.